going to look at friction, just a review from Physics 11, basically, about frictional force. So, to begin with, let's remind ourselves, where friction came from. So, friction is created whenever the surface of one object is in contact with another. Okay, so surface friction, right? So usually we talk about surface friction. I mean, there are also, for example, friction from air resistant, friction from like water resistant if you're in water. But for physics 12, we focus on surface friction. So on the microscopic level, I think I've shown most of you if you were with me last year. So for example, when you see, let's say, like a box and it's in contact with like a table. Now it might look like the box is very smooth, right? But that's just a macro view. So if you have like a microscope or like a magnifying glass and you actually look into it, you see that no surfaces are perfect. So I mean, a very smooth, wooden box on the surface would actually look more like this. So let me pretend that this is the wooden box. So this is like wood. But in a microscopic level, it has a lot of imperfection, right? It has a lot of bumps and valleys and hills, a little tiny imperfections on the surface, and the same thing goes for the table. So the table also has a lot of you know little valleys and hills that you might or might not be able to see. And so what happens is when you want to move, so this is like, let's say, the table. So what happens is that when you try to slide one of them, against the other, then those really sharp corners they run into each other and create an opposing force, and that's what we call friction, right? So for example, you try to move the piece of wood to the right hand side, well then all of a sudden the table, all those little mountains and valleys on the table, little imperfections on the table, they try to slow down the box going to the right hand side. Now, so and that also, like, looking at this picture, it also explains why friction can only slow you down. Because, like, imagine, right, it's like sandpaper. You're trying to push something on sandpaper. Eventually, the sandpapers are very coarse. It's not smooth at all. So eventually, it just slow down, and all the energy from your kinetic energy turns into heat, heating up the wood, heating up the table. So now that we have that covered, let's recall what we learned from physics 11 last year. We have one equation for force of friction. So friction is equal to mu Fn, and this is still true, where Fn is your normal force, and which is always, okay, so this is one thing you have to remember, it's always perpendicular to the surface. So whatever surface your object is sitting on, that friction has to be, that normal force, I'm sorry, has to be perpendicular to that surface. Okay, so how about mu? So mu is the coefficient of friction, and that depends on the material. Okay, so you should have all of these already pretty familiar with, right, from last year. So I'm not going to go too much detail into that equation. So basically, friction is proportional to the coefficient of friction, mu, and also proportional to the normal force, which is Fn. Okay, so let's look at uh, another thing that you learned from last year. Hopefully, you remember that. So there are actually two types of friction, static and kinetic friction. So static friction is the amount of friction to overcome when the object starts from rest. Okay, so that means when your V initial equal to 0. So it turns out that the amount of friction that you have to overcome when the object starts at rest is generally higher compared to if the object is already moving and you just want to keep it moving. So which is called kinetic friction. Okay, so mu, sometimes you will see in some question, they will give you either mu s, which is static friction mu, or mu k, which is the kinetic friction mu. So mu, kinetic friction, mu k, so it's the friction to overcome from like an high force or something like that, right? If the object is already in motion. Okay, so there's an amount of friction to overcome when the object starts from rest, which is static. So you usually get a mu s, and then there's a kinetic friction, which is usually mu k. Okay, so static and kinetic friction. So now we are just going to do a few examples and see how much we remember from last year. Okay, so okay, well, actually, I do have that in here. So in this part, so the object now, so you have to remember that the static friction is always greater than the kinetic friction. So it's easier to maintain something's movement compared to start it from rest, which is always the case. Okay, so we look at maybe this example down here. Okay, so a very basic one. A 3.75 kilogram block is pushed along a tabletop with a force of 45 Newton. Okay, so that 45 Newton is in a pi force. The coefficient of friction is 0.65. Okay, find the force and find the acceleration. Pretty straightforward. We start by drawing the free body diagram, as always. So the free body diagram on this one is a pi force, and gravity, because you're sitting on the table, right, being pushed, normal force, and finally friction. So force or friction on the back. So when you look at this, then now you have to compare vertical to vertical, horizontal to horizontal, and you have to see, okay, so which side should be winning? Most of situations like this, because you're on the table and you don't expect the box to suddenly jump, we'll say Fn and Fg would be exactly the same. So that means if I can get Fg, which is mg, which is 3.75 kilogram multiplied by the force of gravity. So we can actually do that quite easily, and the answer is about 36.75 Newton. Okay, so that's one part. Now, but we also say because Fg is exactly opposite to Fn, and you don't expect a box sitting on the table to suddenly jump off the table, they have to be the same. So in the y direction, you can simply say, well, then I know Fn is the same as Fg. I know that because they point in opposite direction and they should be canceling out. So we have normal force. Okay, so why do we normal force? Well, because we now have this equation to use. Friction is equal to mu Fn. And because mu is 0.65, Fn is what we just found,